right, let's take a look at some practice problems. First of all, letter A, we need to name each polygon, determine whether it is equiangular, equilateral, regular, irregular, or none of these. More than one of these. Okay, so it has to be at least one of them, but it might be more than one. Let's get started. First of all, letter A. So here I'm going to type A. Letter AA, that is a 1, 2, 3, 4, 5, 6-sided polygon, so that is a hexagon. It is equilateral because the sides are the same, and it is also irregular because it is not both equilateral and equiangular. Okay, so that's how I would classify AA. AB, let's see, that has, I'm going to just kind of mentally mark the side I'm starting at where the letter B is. 1, 2, 3, 4, 5, 6, 7, 8. Hold on. 1, 2, 3, 4, 5, 6, 7, 8 sides. Just wanted to make sure. So this is an octagon. Okay. It is equiangular. Look at the angles are the same. 1, 2, 3, 4, 5, 6, 7, 8 angles are all the same. So it is equiangular, but it is not equilateral. So therefore, it is irregular. Okay, letter C. Letter C, oh, this is going to be hard because some of these sides are hard to see. 1, 2, 3, 4, 5, 6, 7, 8, 9. Let me just double check. 1, 2, 3, 4, 5, 6, 7, 8, 9. So this is a nonagon. Nonagon. All right, and it's not equiangular, it's not equilateral, it's just irregular. And then finally, letter D. Letter D is a 5-sided figure, so it's a pentagon. It is equiangular, it is equilateral, and therefore it is regular. All right, so we know now what all of these initial figures are. Name each polygon. If you wrote Steve for one of these, I am just shaking my head. So you name it by the type of polygon it is, by its number of sides, and then we determined its properties. Letter B, find a diagonal. Okay, so let's do that. Find a diagonal in polygon GHJKL. Notice that a polygon is named by its vertices in order. You have to name the vertices in, once you start moving a direction on the polygon, you have to keep going in that direction. So it could be GHJKL, GLKJH, or if I start with H, it just be HJKLG. But what I can't do is HJG because G doesn't come after J. It's not a consecutive vertex with J. So therefore, I'm not able to name HJG. It could be HJK, but not HJG. Okay, anyway, we have to find a diagonal that contains points in the exterior of the polygon because these are both concave polygons. So one of their diagonals strays outside. So for GHJKL, the diagonal HL. And I have to name a diagonal as a line segment, so I'm going to put a line over that. Oh, look at that, nice straight line. Let's try again. One more time here. HL is a diagonal. Maybe if I just draw a line somewhere out here, I could just drag it in. There we go. What is going on today? Whoa, hey, I didn't ask for a calculator. Wow, lots happening. Okay, so I'm just going to drag this over the top of HL, and then we know that HL is a diagonal. Wow, we're already on letter C. Determine whether polygon VWXYZ is convex or concave. Explain. Well, it's obviously concave because WZ, the diagonal, is outside the polygon. I'm not gonna. Oh, actually, I could do this. I'll be true to form here, and I'll put a diagonal, a line segment marker above WZ as well. Okay, next, are polygons GHJKL and VWXYZ congruent? In order for them to be congruent, all of the sides need to be equal, all of the angles need to be equal. Well, let's just see. Side equals side, side equals side, side, no, 3 tick marks, 3 tick marks, 4 tick marks, 4 tick marks, 5 tick marks, 5 tick marks. Let's check the angles. 1 arc, 1 arc, 2 arcs, 2 arcs, 3 arcs, 3 arcs, 4, 4, 5, 5. Yes, they are exactly the same shape because all of the sides are the same length and all of the angles are the same. In addition, they're the same size because clearly all the sides are the same length. So that means that these are congruent. Same shape, I guess you could say that because the angles are all the same, the shape is the same. And then you would say they're the same size because all the lengths are the same. So that's what I'm going to say for this one. I'm going to say for D, yes, it is congruent. Yes, they are congruent. I have to say it for both of them. Congruent. And then justify your answer. All of the sides are the same length. That's the same size. And the angles are the same. That's the same shape. Shape. Okay, there we go. Letter E. For each numbered angle on the polygon, determine whether it is an interior angle or an exterior angle. Well, 1 is interior. 2 is exterior because it's on the outside. It's formed by a vertex, a side that comes to a vertex with the extension of a consecutive side, right? So because of that, or an adjacent side. So because of that, because it's an adjacent side, the extension of an adjacent side, and it's outside the polygon, 2 is external. 3 is internal. It's an internal angle. Because again, it's just 2 sides of the polygon coming together at a vertex. 4, though, is external for the same reason. So 4, external. There we go. All right, let's go on to letter F. Name a type of polygon used in this pattern over here, okay? The type of polygon used. Well, let's see. That's 1, 2, 3, 4, 5, 6. That's a hexagon. And there's more questions here. Are the polygons regular or irregular? They are, look, I see this one is equiangular. All the angles are the same and all the sides are the same. So this is certainly a regular polygon. And then it's just because all of the angles and sides are congruent. That makes it regular. Letter G, pick any pair of polygons in this pattern. Are they congruent? Are they convex or concave? Explain. Well, they all have to be congruent because they're all going to have the same side lengths in order to fit in the pattern perfectly against this one that has all the side lengths the same. The angles are also going to have to be the same for them to fit equally in the pattern. So pick any pair of polygons. Are they congruent? Yes. Are they convex or concave? They are convex. None of the diagonals extend outside of the polygons. And then explain. I think I'm going to explain, I'm being asked to explain the second part. None of the diagonals extend outside the polygon. If I had to explain the first part, I would explain that they are congruent because all of the sides and angles have to be congruent, and therefore the shape and size of the polygons are the same. All right, that's how you work problems related to polygons. I think you'll find that polygon problems are pretty easy because it's a lot of identification at this stage. However, we are going to get to a point where we are doing some math with polygons. You're going to have to memorize some properties of polygons, and that's when things are going to get hard. But for now, enjoy a relatively easy lesson. Ta-ta for now.